So we are looking for justifiable work practice for the questions on the test that are dealing with IVT. Okay, so let's do number 11. It says the function f is closed on a to b, so it's existing between these two numbers, inclusively, with the endpoints. Show whether the conditions of intermediate value theorem hold for the given value of k. Guys, I know it's been a while because we're now doing a lot of unit 2. What did the k value represent?
The
Y value. If the conditions hold, then find C where f of c would equal k. In other words, where they would intersect. Where that y equals 3 in this case would intersect this graph. Okay? If theorem does not hold, give the reason. Either way, we're going to sketch. So here we go. Guys, what shape are we sketching when we see something that looks like that? What is it? It's very close-ish, yeah? Square root. It's a parabola, or square root is where people always go to, but you'll least expect what it actually is. It's not linear.
Absolutely.
So here we go.
Yes.
No. Y is equal to square root of 25 minus x squared. You are not used to seeing it in this form.
What if you took out a -1 and then did
No worries, no worries, no worries. Thank you. No worries. I'm going to square both sides.
a circle?
It's a circle.
What?
So if I add the x over, this is actually a circle with a radius of 5.
So then there'd be multiple.
Whoa, careful though. It was only, you know how square roots have a plus or a minus?
Oh my.
This is only the top part because it's a positive square root. You with me? And these are easy to forget. Please put this in your brain because they are easy to forget. These square roots with x squared pieces, if you do the manipulation that I just did, will be circles. Okay? This is -5. This is 5 because we know the radius is 5.
So how do you know it's only the top half again?
Because right here, it was given to you as the positive version of square root of x. Think of like vertical reflections across the x-axis. The square root of x looks like this. But the negative square root of x looks like this. But we typically don't write both of them because it would fail the vertical line test. You with me?
So would that just be like a negative vertical shift or -1 for like a vertical strip?
There's not a stretch, it's just a reflection. Think of a reflection across the x-axis. Okay? Now here we go. I'm looking at -4.5, which is about here, all the way to 3, which is about here. And this is the only piece of the graph that I'm actually drawing per se. Are you with me? We know that this goes all the way to 5, and we know that we're looking for y is equal to 3. Okay? So at -4.5, I can plug this in to my function here, which I need to, because let's do the intermediate value theorem. First of all, this midget, this piece that I'm going to highlight in, let's say, orange, this is what I'm really looking at because of where it's going to be drawn. Okay? So this piece that I just highlighted is f of x continuous. Yep. So you're going to say f of x is continuous on -4.5 to 3. And guys, these words have to be pretty much exact. Okay? So this is what I was wanting you to do that flip grid so that you could practice, but now just practice on your own. Okay? What's the second step of IVT?
They don't equal each other.
that they don't equal each other, right? So we gotta check, what is the y value at negative 4.5? What is the y value at 3? And we gotta make sure that they don't equal each other. Now, I drew a rough sketch, but you would plug this into the equation and see what you would get. And obviously, they're not gonna equal each other.
So we're not gonna have like the blanks like we did on Delta Math.
No. Yeah, you're gonna, no, you will, thank you for bringing that up. You will not have the blanks that you're gonna fill in on your test. You're gonna have to show all this work by hand. Yeah.
And to show that f(x) is continuous, you have to draw a graph.
So, okay, listen to
Is there a
this.
different way to-
Listen to this. F of x is continuous because I know that the parent function almost has a square root piece to it. And because this x squared, it's like a quadratic piece. But here's the thing. We know that it was a circle. Right? So you do have to, on this particular one, for sure, know what the graph looks like to see, did I ever lift up my pencil? You with me? Man, your question is really good, actually, because here's the thing. What is the domain of square root of x? It's bigger than 0. The domain is 0 to infinity, with 0 included. You with me? What's the domain of x squared? All real numbers. And if I overlap those two, you would assume that it was only continuous 0 to infinity. But with this graph, it is continuous even in the negatives, even though I have a square root. Because I don't really have a square root function. I have a circle, a piece of a circle. Nicely done. So on this one, yes, you would have to graph it to see if it was continuous.
But not all functions.
Not all functions you have to do that for sure. You just have to know what the parent function looks like.
How would you like prove that it's continuous?
That's what I'm saying. From this, knowing that this graph, knowing the graph, you would have to know that it's continuous.
Like, what would you write on the test?
Just this, f of x is continuous. Because if it wasn't, you would write f of x is not continuous and you would stop. And I would know that you know it's not continuous right off the bat.
It's only supposed to do steps 2 and 3 though.
Yeah.
Even if it's not continuous.
Oh yeah. Oh no, you can stop. And I only did those examples with the more work so you could get more practice. Because I didn't know if I could have time to do these videos that I'm doing now. Okay? So if it once it fails, you can stop. And you can say theorem does not hold, therefore I cannot prove that it's I can't prove the rest of IVT. You know what I mean?
Said there may not exist the value.
Yeah.
And that's the word you use.
That's
there
it.
may not exist.
Mhm.
Okay.
Or there doesn't have to exist a C value between A and B where f of C equals K.
So if it's not continuous, then it could be the may not exist. But when will it be there will never exist? Is that only when you know
Yeah, because on the
That-
Delta Math there are some.
where it says like it
Oh.
does not exist?
Um,
Would that only be where there's like a discontinuity at the specific K?
yes, and only connect that, I see your questions, only connect that with delta math. Don't connect that with this.
Okay.
Okay. So this is true, this is true. What is rule 3?
That they.
That K is between what? F of negative 4.5, yep, and f of 3. So we just have to verify, is y equals 3? And again, for the sake of time, I'm not finding what these are. Okay? You can plug them in and see what the square root of that answer would be. And you could use the calculator on that for sure, right? And then we're just going to know that they're different, but also at the same time, K is going to be between f of negative 4.5, which, I don't know, it might be like 1 or 2, and then f of 3, which might be, I don't know, like 3.5 or 4.
Wait, isn't K above that? Oh,
K is
just you
3.
drew it above it, but isn't it?
Oh, my bad.
It's actually below.
Thank you. No worries. I'll just change it just real quick. How far did I go?
His K value, he drew it above them. And
Thank you for the
so
catch.
it has to be between them.
So this will definitely be between the two y values. Thank you for this catch, especially on the video. My k y value will exist like here, in between this endpoint and this endpoint. Go with me, guys? In between those y values is where this horizontal k value, in this case of 3, is going to exist. Okay? Yeah.
So not on both, not on 2 points.
Possibly. See, I should have done this. Let's do this with the calculator real quick. I want you to put in your calculator the square root of 25 minus x squared. And you can save it. You can save it as f of x. So control vars f of x. And let's find out what is f of negative 4.5. Okay, sure. What is it? So it's 2.18179. Yeah, for sure. And what's the other one, Jordy? What is it? 4. So between 2.179 and 4, those are the y values, and sure enough, k is equal to 3. Y'all can see that it's going to be in between. So y'all tell me what the answer is. Is it going to be at 1 or 2 different places? Just at 1 in this one, right? Just at 1. Okay? And it's going to be right here at whatever this x value is, right there.
But
This
if,
is that c value that we're going to find.
But if the like f negative 4.5, if it was like negative 2 or whatever, and that was like a wait.
Yeah, it could be more than 1.
Yeah.
Yeah, for sure. Okay? But just drawing out the graph, we know it's going to be only 1.
Like this. Let's say that.
Okay? So let's keep going, guys. So these are all true. Therefore, there must
There's more values, right?
exist a c value
So the rest of the y values would be
between, or you could say on, negative 4.5 all the way to 3 with parentheses, because you're not saying including the endpoints. They have to be in between. So these parentheses are very important here and very important up here. Where what? Where f of 3, or no, sorry, where f of c equals 3. And then now the last part, and I think we only have time for this one video, no worries, I'll record the other ones, is we're going to solve for it, and I'm going to show you right here of how I want you to solve for it on the test. My original equation was f of x, but I want you to write it as f of c, because you're finishing the proof out. So it's the same function, only with c's. And we're saying f of c is 3, so we're saying 3 is equal to the square root of 25 minus c squared. And now we're just going to solve for c. So we square both sides, we get 9 is equal to 25 minus c squared. Move the c squared over here, subtract the 9, we get 16, right? And what are my answers right here?
It would be plus or
It would be
minus
plus or minus 4.
but one of them is extraneous.
But here we go. One of them is extraneous because it's not in between. It's not going to be hitting the graph per se.
And on one like circles, there couldn't be more than 1 point because then the y values would not be, or the k value wouldn't be in between the two.
Correct. So you tell me, guys, which one is the correct answer? A positive or a negative in this? Positive or negative 4? It'll be a negative 4. Now watch. To finish this off, I need to know what I'm looking at graph-wise. I need to know how much of the graph should I actually have drawn to begin with. I need to know how to reference this y value horizontal line. And then I have to go through all the steps with correct parentheses or brackets, with correct notation. Notice that I did not put 2.179 right here. That's not how the theorem is defined to be used. I did let k be between. Notice again my usage of variables. And then my therefore there must exist a c value between or on negative 4.5 to 3, where f of c is equal to 3.
And then the C plus 1 is 4.
And the c is going to not be that plus value. So the answer, because plus is extraneous in this particular one, would just be the negative c. Or sorry, negative 4.
How many points would there be total?
There's only one on this domain that we're looking at.
No, like,
How much is it worth?
yeah.
Oh, these are going to be like 9 or 10 points each, at least.
And can you go through and like, so
I-
so that wherever there's green, that'd be a point.
Yeah.
That would get.
Everything that I was circling would be a point. Yes.
So if one of the proofs, or like one of the things,
If one of these does not hold, then you cannot guarantee all of this.
so you don't have to do the other.
No. Once it doesn't hold, you could say theorem does not hold, therefore it does not guarantee, or there does not have to exist, however you want to word it.
There was a question that, like in groups,
No, I know, and I only did that so I could get you to get more practice.
but it's not going to be on the test.
But it won't be on the test. If it doesn't hold, you tell me where it doesn't hold and you can stop. Yes?
So, so you said that with delta math, just ignore how on delta math there was like, there does not exist, so it's, the answer will always be on these types of questions, there exists or there may not exist?
Yeah.
Okay. And is it okay if we put there exists instead of there must exist? Or does it have to be there must exist?
You could say there exists.
Okay, cool.
Are we good?
We're more than good.
Alright. Nice job on that, guys.
One last thing.